Good afternoon, बच्चे. Good afternoon. So, in previous class, we have discussed product of electrolysis. Okay. So now the today's topic is battery. So this is the last topic of the electrochemistry class 12 chapter. So first, what is the principle of battery? The battery principle is based on galvanic cell. And all of you know what is the principle of galvanic cell? Yeah, means the chemical energy convert into electrical energy. So batteries simply it's a galvanic cell or electrochemical cell, and its principle is same as we have already discussed. That is chemical energy convert into electrical energy. Then how battery is different from cell? So basically battery is a combination of cells. So battery is a combination of cells which are connected in series. So when many cells are connected in series, that is called battery. Okay. For a good quality battery, it should be reasonably light. How we'll think about the battery? Which one is good battery? How we can decide what is the quality of the battery? So the good quality battery is a light. It should be light, compact, so that it can be easily, conveniently can be carried out and we can travel anywhere. Its voltage should not vary appreciably during its use, means it should not be very much variable. So the good quality of battery is like this. It should be light, compact, voltage should not be appreciably during its uses. Okay. Now, when we use a battery in day-to-day life, we actually, everything which we use in day-to-day life by which we get the electricity, that is battery. When we use torch, when we use toys, remote battery, even car battery, even our fuel cells, that is a rocket we launch, even during the dialysis process, the body where is a battery is required. So the battery is used in day-to-day life in so many places. Okay, so battery which we use in daily life, they are basically two types. So battery are two types, primary and secondary. What is the meaning of this primary and secondary? Primary battery means the reaction which occur only once and cannot be reused or cannot be recharged. So primary battery is not rechargeable battery. Secondary battery, which is also called rechargeable battery, means after we can reuse again and again after recharging. And very common example of primary battery, that is dry cell, or this dry cell is also called Leclanche cell. So we will discuss, there's so many examples, but we will discuss two examples of primary battery. One is a dry cell, and you know where is the use of dry cell? We use in clock, we use in toys, we use in remote battery, and etc. Mercury battery, which is also called button cell. So which we use in our wristwatch, even laser, hearing aids, etc. Secondary battery, which is a rechargeable, and we will discuss the two examples of secondary battery, and that are lead storage battery, which use in the inverter, even in car battery, and the nickel cadmium cell. Okay, so now first we'll discuss the primary cell. In primary cell, we'll discuss first what? Dry cell. And this dry cell is also called Leclanche cell on the base of scientist name who discovered this, who proposed this cell. Even you have seen this dry cell in daily life, which is also called Dura cell. Okay, this is a ever ready battery. So this is nothing but it is a dry cell. Even you have seen in this dry cell, the voltage is mentioned. I think that you are able to see, just okay, you can see what is the voltage over written here. So when you see the battery at home, you can see the battery voltage is written 1.5 volt. So basically its cell potential is 1.5 volt. And you have seen there's a charge is also mentioned plus, minus. At the top, plus is mentioned, and at the bottom, minus is mentioned. So plus indicates, all of you know, the plus in electrochemical cell, plus indicates what? Cathode, and minus indicates anode. So when we talk about the cell, always there is a two electrodes, anode and cathode. Anode is negatively charged, cathode is positively charged. So this positive charge is mentioned at the top, nearby this. This is nothing, it is a brass cap by which connections of, suppose when we are putting this battery in the torch, so this is just connection. Okay, this is just like a cap. But inside there is a rod is there, and that rod, that is a carbon rod, or we can say graphite rod, and that is basically act as a cathode. And at the bottom, when you see the battery, when you open the battery, and when you cut the battery, open the battery, you can see at the bottom, even you can see at the bottom even also, the grayish color is there. And that gray color is zinc. So by this, we can easily know about anode is made up of what, cathode is made up of what. So in any cell, whether primary or battery cell, what things we have to know? Anode is made up of what? Cathode is made up of what? What electrolyte used in this? What is a cell potential? What is a cell reaction? And uses. So in any cell, we have to discuss about all this thing: anode, cathode, and the anode cathode reaction, that is cell reactions, electrolyte, what used, what is the cell potential value, and where the use, and even advantage or disadvantage. Okay, so when you see this dry cell, you can easily see this is a container, is a zinc container, and this zinc container is nothing but it is anode. There is a graphite rod, which is cathode, and this graphite rod is surrounded by MnO2 powder plus carbon powder. So basically cathode is made up of graphite rod, and which is surrounded by manganese dioxide, black powder plus carbon to increase the surface area and for the reaction. And the electrolyte is nothing but that is a paste of ammonium chloride. Now you can see, again I'm repeating what I told, just tell me. Anode is made up of what? Zinc. Cathode is made up of graphite rod surrounded by MnO2 powder plus carbon. Electrolyte, it is a paste of ammonium chloride and a small amount of zinc chloride. What is the cell potential? 1.5 maximum, but the range is 1.25 to 1.5. And now what is the cell reactions? Cell reactions means what is cathode reaction, what is reaction occur at anode. Okay, anode is made up of zinc. So zinc oxidizes into zinc 2 plus by loss of 2 electrons. Okay, cathode is made up of what? Carbon rod along with MnO2 powder. So at anode, zinc is getting oxidized, and at cathode, this MnO2 powder reduced in presence of electrolyte. So electrolyte role you can see ammonium chloride, but we are taking only ammonium ion. So MnO2 reduced in the presence of ammonium electrolyte by gaining 2 electrons into MnOH. So what is the oxidation state of MnO4, Mn in MnO2 plus 4, and here it is plus 3. So you can see oxidation state changes from plus 4 to plus 3, means reduced by gaining electron. And this ammonium ion convert into ammonia and water. And then after you can write the overall reaction. So what is the overall reaction is coming? Zinc plus MnO2. Basically, first you can write the skeleton equation like this. So then you write overall reaction, right? Zinc plus 2MnO2 plus 2NH4 plus, and electrons will be cancelled out, these two electrons. And the product side Zn2 plus MnOH plus ammonia plus water. So this is cell reactions. So in cell reactions, you have to write anode, cathode, and overall. Okay, in this reaction, you are seeing there is a formation of zinc 2 plus ion at anode and ammonia at cathode. So this zinc 2 plus ion react with ammonia, which is formed at cathode and anode, to form a complex ZnNH3 whole for 2 plus complex, which is soluble. So this is the reason that dry cell, even we don't use dry cell, after a long time, the leakages start. So what is the reason the dry cell, the leaking after a long time, when it is used or when it is not used even also, just because of when it is used and or not used, small amount of zinc 2 plus ion and ammonia is releasing, and these two combine with to form complex, and this complex is nothing, it is soluble watery form, so it's come out from the cell. So dry cell, even you can see over here also, I just mentioned here also, that dry cell do not have a long life, as ammonium chloride is acidic, and due to acidic, its corrosion occurs. It corrodes the zinc container even if the cell is not used. Even you see ki battery is discharged, right? Okay, electrochemical cell means we are using, and when we are using, the cell potential start decreases. But in dry cell, when you not even don't use, there's expiry date mentioned, means after long time of interval, it discharge and is not used. So why? Because this reason only, because ammonium chloride, which is used as an electrolyte and which is acidic in nature, and hence the zinc container, which is act as a anode, start corrode. Okay. And already I've discussed what is the use of this dry cell in daily life. You can see it's used in wall clock, alarm clock, camera battery, calculator, even toys, mouse, remote control, electronic balance, torch, and so many other places. So these are the uses of this dry cell. I hope it is clear. Okay. So now the next topic is mercury cell. Mercury cell is what? It is also called button cell because of its size only and no any another reason. You can see it's just like a button cell. This button cell is nothing but the mercury cell because mercury is there. Okay. Now we see in this button cell, anode is made up of what? Anode is made up of zinc, amalgam. Cathode is made up of paste of mercury oxide plus carbon, electrolyte, paste of QH and zinc oxide. Now the cell reaction, anode is made up of zinc. Amalgam is not reactive, only zinc reacts. So again, zinc amalgam in with zinc oxidize into zinc oxide in the presence of electrolyte. So what electrolyte we are using? KOH. So that is OH minus, basic medium. So this is basic, in this basic electrolyte is used. So again repeating, anode reaction, zinc in the presence of OH minus oxidizes into zinc oxide by loss of 2 electrons and water. Now cathode is made up of HgO, that is mercury oxide. So this HgO accept this water and electron, the same water and electron, zinc एनोड पे जो लूज हो रहा है, cathode is accepting the same thing. So at cathode, this mercury oxide accept these two electrons and water to convert into or reduce into mercury and loss of OH minus. So in overall reaction, you can see everything is cancelled out. This OH minus, electrons, water. So what are left? Zinc plus HgO gives zinc oxide plus Hg. So you have to learn this reaction. Its cell potential is what? What is the cell potential? 1.35 volt. So where is the use of this button cell? Its cell potential is low. So this is used in the low current devices like watches, hearing aids, as the potential value is low. This cell shows constant. This is the one very important advantage of this battery. So what is the advantage of this battery? The major advantage of this battery is the cell potential remain constant throughout the life. Even questions come, why the button cell or mercury cell potential remain constant throughout the life? So its cell potential remain constant throughout the life because you can see in overall equation, no ions are involved. You can see in reactant side, product side. Is there any ion? कोई ion दिख रहा है? नहीं. So no ions involved in overall reaction. So this is the reason cell potential remain constant at the last day of the life. As for one example, when we use our wrist watch in which the button cell is there, and you have noticed it even also, when we are using this button cell in our wrist watch, the batteries, okay, reaction is going on, electricity is produced, and our watch is working, running, time is okay. But suddenly what happens, suppose today my watch is running and suddenly early in the morning we see the watch has suddenly stopped. It's not working. So this is the reason कि its potential remain constant last ion produced and suddenly stopped. Otherwise हमारी जो बैटरी में जो ड्राई सेल में होता है, जैसे क्लॉक है, वॉल क्लॉक, व्हाट वी सी, हमारी वॉल क्लॉक चलती रहती है, बैटरी डिस्चार्ज हो रहा है, बट वो सडनली स्टॉप नहीं होता है, धीरे धीरे टाइम स्लो हो रहा है, 2 hours स्लो हुआ, 4 hours स्लो हुआ, बट इट्स नॉट सडनली स्टॉप. बट इन दिस केस द सेल पोटेंशियल, जब तक इसका एक आयन भी प्रोड्यूस होगा, हमारी बैटरी चलती रहती है, हमारे रिस्ट वॉच रन करते हैं. And one ion, the last ion consumed, then suddenly the wrist watch stopped, and hence we say its cell potential is remain constant till it works. Right? So this is the one major advantage of the mercury cell. You can see where is the use of the mercury cell. Already I told this is the size of the mercury cell used in the wristwatch, even hearing aids, even leisure, even calculator, and etc. So these are the two examples of the primary cell, or that's not rechargeable cell. Okay.